Next manufacturing process is like a rotational molding. This process is used for the manufacturing of the hollow, seamless product of all size and shape. So I will explain how this manufacturing process is work. In this one, you can see that placing the powder into the mold and close. So this is the mold where the plastic material powder is being placed. So the mold will be placed in the heated oven, and the mold is heated by the forced hot air and circulated. So what they do means, after placing of this powder into the mold, they are going to just heat this oven, this mold, and they are be heated by the force hot air, and later they have been rotated into two perpendicular direction. You can say, while the mold is heated, it is rotated about the two perpendicular axes simultaneously, and the mold is moved to the cooling station where the force air cools the mold. So what they do means, after heating, they are just going to rotate the mold. You can say actually in this direction it will rotate, and perpendicularly, like if you are seeing from this side, it will rotate in the clockwise direction. So then later it is allowed to cool. So you can see the profile how it looks, and later they are removed from the mold. So these kind of components, they are generally used for like big water tanks. So you see for this manufacturing process is being used. The next manufacturing process is like a hot runner mold. In this one, the system includes the assembly of heated components, which includes the manifold and the nozzle. So this manifold helps to maintain the constant temperature of molten plastic material in runner. Molten plastic material flow through the nozzle and fills the core mold to form the final shape. So here you can see that in the diagram, here there will be a nozzle which consists of this area is known as a manifold, and this is a nozzle. Yes, in hot runner mold, there will be a nozzle. There will be a main manifold will be there. In manifold, there will be a nozzles, like if there is a multi-cavity, like 2 or 3 nozzles will be there. So in manifold, the plastic material is being heated, and it will be with a very high pressure. It will be injected into the core and cavity, and we are going to get a required component. The hot runner mold is generally used for the very large components, like creating of dashboards or car panels. For those kind of components, the hot runner mold is being used. So here I will be giving just a small introduction to the molds. So almost like 80% of industries use the plastic injection molding. So I will just explain what is the mold. Here the picture, what you see, this is the mold. I will just explain the basic parts of the mold. This is known as the top plate. The second plate is known as a cavity plate. So in the cavity plate, there will be insert. So the insert where our main component is going to produce, for that insert is known as, we call as a cavity insert. So this is the core plate. So in the core plate, we'll be having a core insert. And behind the core plate, there will be a core back plate which supports the core. And these two plates you are seeing, it is an ejector plate assembly, so which helps us to eject the component. And these two pieces are known as the spacer blocks. This is a guide pillar, and this is the bottom plate. So on the ejector system here in machine, there will be one rod will be there, so which just pushes this plate. So which works as the ejection system, which eject the plastic component out of the mold. In this picture, you can see that here you can see that the small diameter, what you look, it is known as the ejector pins. So the parting line, gates, and ejection, I will be explaining in the other pic. So next comes to the plastic design guidelines. In order to design any components, plastic design guidelines are very important. If you follow the plastic design guidelines, there will be the part which we get, it will be a defect free. So what are the major guidelines we follow? The first thing is like a wall thickness. So the plastic part, what you design, it should be always like uniform cross section component should, uniform thickness it should be there. If there is not a uniform thickness, then the problem arises. So when the molten liquid is injected into the mold, the thin cross section starts cooling first, and then the thicker cross section starts cooling. This irregular cooling in thickness causes the parts to sink, and the stresses are built up into the areas, which leads to the warpage, voids, and the twisting of the parts. So what will happen with if there is not, here I have shown in pic. So if you are not going to maintain the uniform thickness, then we are going to get many defects like voids, warpage, and the stresses are going to cause, and the sink marks are going to be created. In the first thing, you can see that at this region, the sink, here you can see that here the thickness is different, and here the thickness is different. At this region, the sink marks are created. And if you come to the second diagram, you can see that here also, due to non-uniform thickness, voids have been created. And in the third diagram, you can see that at the region where the non-uniform thickness will, where the intersection place where the high thickness and low thickness will be there will be high stresses areas will be forming. And you can also see that the component will just get bent. In technical terms, we call it a warpage. So how to overcome this one? So in order to overcome this problem, we always should provide the component at the uniform thickness, but industries sometimes it is not possible to do it. So how to produce the component with the variable thickness means I will just show by the example. Here you can see that there is a variable thickness is there. So what you need to do means the intersection area where the high thickness material and the low thickness material meets, you need to provide a very good and very large amount of radius at the end. So it reduces the stresses. There should not be any sharp edge, as I said, that it causes the stresses. So next one is the radius. So the sharp edges cause the high stresses and also restrict the flow of the material. So you have seen that what will happen if there is a sharp edge in the component, what are the problems we are going to face? Means the sharp edges causes the high stresses and also restrict the flow of the molten material, and it reduces the part strength and stiffness. So the thing is, the sharp edges causes the high stress and also restricts the flow of the molten material. And the second thing is that it reduces the part strength and stiffness. And the third thing is that the problem in the tooling, which reduces the life of the tool. So there is some terminologies some thumb rules we are using into the plastic design, that for giving of the radius, so the minimum radius should be like 0.5 times of the nominal thickness of the component, and if it is very high stress part, we should give like 0.75 times of the nominal thickness of the component we should give. Now the third main important feature is like a draft. So draft is provided to the direction of the part release. So due to the shrinkage in the plastic material, the parts tend to shrink with the core, which creates the higher contact pressure on the core surface and increases the friction between the core and the part. Hence, we need to provide a required draft angle. Here you can see that in the right side, there is a red component without any draft. This is the core and this is a cavity. So what will happen, so when the molten material will be placed in core and cavity, after the plastic material gets solidified, it tends to shrink with the core. So what happens means it tends to stick means it tends to stick with the core. During that condition, if there is no draft, there will be some stresses are being created in this region. So due to this reason, the core will get wear and tear, and the life of the tool also will get reduced, and Component ejection also will be very difficult. If you provide with a proper draft, you can see that from this surface, if it comes like 1 to 2 mm, it will be properly ejected without any problem. So the draft we generally in provide industries are like 0.25 to 2 mm, depending upon the length and the thickness of the component, and also depending upon the plastic material. The next one more important function is like a rib design. So the ribs are generally helps to provide the strength and the stiffness of the part. So you can see in the here you can see the peak. So these are the ribs. So for designing of the ribs also, you should know that how the load is coming and how the function it is working, because providing the rib in the wrong orientation doesn't work out. Here in this case, you can see that in the right side, the load is coming over here and the reaction force sources are over here. If you provide the rib parallelly, you can see that it doesn't work out. And here in the left hand side, you can see that here they have provided a rib at the center of the component, so it provides a stiffness to the mold part. So we should plan and design the rib. So there are certain guidelines of providing rib also, so that the rib height should not be more than 2 to 3 times of the nominal wall thickness, and the wall thickness, and if it is coming into the pitch, it should be like 2 to 3 times of the pitch around the length. The next one is like a boss design. So the boss feature in the plastic is used to accommodate the thread and the screw feature. These features is subjected to the loading conditions, and certain guidelines we need to follow like that. Here, like, you can see that the height should not be more than like 5 times, and the outer dia should not be like more than 2 times. A minimum 2 times 2D it should be there, and the radius should be like 0.2, 0.5 times, and if your depth is there, like it should be more than 0.7 times. So these are some standards we need to follow it while designing of the bosses. So apart from the design guidelines, we should know that certain part design essential factors, like what is meant by shrinkage, what is the parting line, what is the tonnage, what is the runner. So I'll be just explaining. So shrinkage means a dimension changes occurring to the part volume as it cools after the injection molding. Example I will show over here. Here you can see that this is like core, and this is a cavity. This is the area where our plastic material is going to be insert through the nozzle. This pic shows that the plastic material is already injected. So what is the shrinkage means? Consider there is this diameter is like 10 mm, okay, and the length is 10 mm. Okay, our physical part, what we require, the dimension is like 10 mm diameter and 10 mm length. So actually in core and cavity, the dimension will be very more. I mean to say that when the plastic part cools, it will just decrease in their dimension. So this change in dimension or volume is known as shrinkage. For different material, different shrinkage values will be there. So consider for this plastic material is like 0.2% of shrinkage is there, means then in mold the value of this dia will be like a 12 mm and the length will be like a 12 mm. So after when it get cools, the component what we get will be of dia 10 and length of 10 mm. So next is a parting line. A parting line is the line of the separation on the plastic part where the two of the plastic injection mold meets, that is core and cavity. So here you can see that in this case the parting line is here where the core and cavity meets. The next one is a tonnage. Tonnage is a measure of force that is required to keep the tool in the closed position. And next is like runners. So in this pitch, you can see that red highlighted what you are saying, it is known as a runner. So the picture what I'm showing, it is like multi-cavity mold. Multi-cavities means if in mold, if there are like a number of components like 2 number, 3 number, 4 numbers are components were producing the mold, we are known as a cavities. In this pic, you can see that it is a 4 cavity mold. Okay, here the red one what you are highlighted, it is like it is a runner. So the plastic material from the sprue, it is from the nozzle, it will be coming from the sprue. Okay, from sprue it will be divided into the runner. The plastic material will move from here. This what you see the highlighted, it is known as a runner. And from here the blue color what you known as a gate. So the plastic material, molten plastic material will come from here. From gate it will be just poured into the cavity. So runner and gate, I have shown that this is the runner, and this is the portion what you see in the blue color is a gate. And next coming is like ejection system. So in mold, when the component, it will be in core and cavity, so the cavity portion will move up. You can see that at here the cavity will move up. So during that the component will be get sticked into the core. So in order to remove this component, the ejection systems will be there. So as I showed in the mold base, the ejection system will work and it will eject the plastic component out. So there are different types of ejection in molds, like pin ejection, stripper ejection, sleeve ejection, and blade ejection. So a few ejections are basically used in the mold design. So next one is like undercuts. If into component there is any hole is coming, consider for this component, if there is any hole is been there like perpendicular, like parallel to this line, while during ejecting it causes the undercut. So in order to remove that undercut, we should provide this slide system. So in mold there is an option known as a slide. So it just pushes the slide back and later the ejection is been done. Next is a thread inserts. These are the thread inserts are like a metal insert having the female thread in it. So these thread inserts are generally placed into the bosses. So during molding, these thread inserts are placed as a loose inserts in the mold. When in plastic injection mold, when the material been injected, so it will just there will be some grooves on these thread inserts, so it just gets stuck into that bosses. So next one is the CREO module software. So what and all the modules we are going to use in a CREO for the creation of this plastic design are like a part modeling. So part modeling feature and sketcher feature, module we are going to use. In this part modeling, in the sketcher module, we are going to do like a 2D sketch, and we are going to create feature option in this one. And in part modeling option, we are going to use like basic options like extrude, revolve, sweep, cut options we are going to use. So some basic tools we are going to use. And in the part modeling module, we can create the simple to complex design of the plastic parts according to design guidelines. And the creation of the and components also created by these surface options we can create in the part module. And we can create the class A and class B surface. So the class A surface are those surface which have the aesthetic look. So on this class A surface, there will be no any parting line or gate mark or ejection marks will not be there, will not be visible. So and the part B surface is the surface where all these parting line marks, gate marks, ejection marks will be seen. So these features we can do in part modeling, and we can do the parting line analysis and draft analysis in the part modeling. And we can also plan the core and cavity in part modeling module. And we can also plan the side cores in the part modeling module. And the next module is like detailing module. In this detailing model, you are going to just dimension the parts as per the manufacturing dimensions, and you can apply the GD&T and other detailing commands we can apply in the detailing module. And the next module is like assembly module. In the assembly module, the piece parts you have been created, you'll be assembling at one location. So there are many options like assembling of parts, replacing, interchangeability, and other parts options are available. So this replace is like the option, like considered by mistake. There is one assembly you have assembled like M10 screw. So you need to you have assembled M10 screw around 100 presses, and you need to modify that screw or screw of M12. So just if you give the option replace option, and if you show the part which you need to replace, automatically it replace in all the locations. This replace option is being used. And one more module is a mold manufacturing module is there, so where you can design the core and cavity over there. You can design their gate runner, things you can design. And this ejector system you need to design in mold base tonnage. You just need to do few calculations for the calculating the tonnage.